Hi and welcome. In this video, I'm going to introduce the sine and cosine functions and just talk about the basics of what they do and how they work. So our motivation is if we have an angle that we draw on a circle in standard position, we could have the angle, we're going to call that angle theta, and on these xy axes, we might want to know what is the point that this angle points to. So what are the coordinates of this point? You can imagine that in lots of situations, we only have information about the angle something is going or the angle that a situation is occurring in. Maybe we just have the angle. We don't have a really complicated exact function that explains what's going on. We just have a little piece of information like the angle. Well, being able to use the angle and then find more information, like the point associated to it, could be really powerful. So this is something we're interested in doing, is if we just know the angle of some situation, what is the point that it's pointing to? So to write that out, we would say that if we have an angle theta, we want to know what are the coordinates of the point that are indicated by its terminal side. So that's just a more formal way to say what I sort of explained more casually. So the way we're going to determine these coordinates is by defining a new function that represents them. We are going to define the functions sine and cosine to tell us the coordinates. So we're going to have a way to find the coordinates, but we have these functions that represent them. So I like to think that we didn't just go out and discover sine or cosine. It's not like it just existed. We create these functions and we define them to do the specific thing we want, which is to find the coordinates that are pointed to by an angle. Of course, once we have a function, we can think about it in lots of different ways, but this is just one sort of interpretation of it, is that sine and cosine are related to these coordinates. So let's put a little more information here on our picture to help us define these functions. So you can imagine that we have some radius r of our circle, and so that's the length of that terminal side. Then we are going to have some x value that we go over, at least in this picture, and then up some y value. And this makes a triangle, so we have one side that is x, one side that is y, and then one side that is r, the hypotenuse. And that x and y correspond to the coordinate point, so the xy point. So x is one side of the triangle, y is the other side, and this is like the point xy. So given that we're trying to create functions that help us determine the x and y, we're going to define sine and cosine using ratios of sides of this particular triangle. So we define sine as sine of theta is equal to y divided by r. So the function sine takes in an angle theta, and it tells us the ratio of the sides y over r. Then cosine is going to look similar, so cosine of theta is x divided by r. So cosine takes in an angle theta and outputs the ratio of the sides x over r. Now, given this, we can actually solve for x and y. So remember, our whole point was to get something about x and y, so we're trying to determine that point. So if we solve for x and y in these, we get y is equal to r times sine of theta by multiplying the r over. And similarly, we get that x is equal to r times cosine of theta by multiplying the r over as well. So this means that in our picture here, instead of the point x, y, we could actually label it as r times cosine theta for our x and r times sine theta for our y. So these cosine and sine functions give us information about the x and y. So okay, in this circle we had a radius of r, but we like to make things as simple as possible in math, especially when we're trying to define things for the first time. So to simplify this whole situation here, we're going to consider the unit circle. So the unit circle is a special circle. It has a radius of 1. In math, when you hear the word unit, it often corresponds to the idea of 1, whatever that 1 is. And so here our unit circle has a radius of 1, and it's centered at the origin. So centered at 0, 0. And by considering a radius of 1, things are going to get a little easier. So let me highlight this. So if we have a radius of 1, now everywhere we had an r in all of our formulas, we're now going to have a 1. So we defined sine and cosine in general, and now I'm looking at what happens if we look at a specific circle which has a radius of 1. So now we have that y is just equal to sine of theta, and x is just equal to cosine of theta. So our sine and our cosine tell us specifically the y and the x. then we would label our point as cosine of theta, sine of theta, as our x and our y. So as our goal was, or our motivation was at the beginning, we wanted to have coordinates for this point, and so we have made them as cosine and sine, at least with the unit circle specifically. Okay, so let's summarize what we just learned. So our process is that we are going to define the functions sine and cosine as sine of theta, which is equal to y over r, and cosine of theta is equal to x over r. So these are functions, they take in an angle, and they output a ratio of sides. They work for either degrees or radians. The idea is just that you give it an angle and it tells you this ratio. Then this means that on the unit circle, any point x, y can actually be written as cosine, sine. And that's because a unit circle has a radius of 1. And so the r value in these formulas becomes 1 and essentially isn't there anymore. And we can relate this to a right triangle. So if we have our triangle with our angle theta, and we label the sides x, y, and r, another way that we're going to refer to these sides is by giving them names. So we're going to call the side length opposite of the angle the opposite side. So you can imagine standing at the angle and looking across the triangle, you would see y on the opposite side. Then if you were standing at the angle and looked right next to you, you'd see the adjacent side. You'd also see the hypotenuse, but the adjacent is just the one that isn't the hypotenuse. So the adjacent side is x, and then the hypotenuse is the longest side of the triangle, and it's our radius r. So we can actually rewrite our functions as sine is opposite over hypotenuse, since it's y over r, and cosine is adjacent over hypotenuse, which is x over r. Also, just one more thing, we often consider sine and cosine as part of trigonometry, which is a math word like calculus or algebra or even statistics maybe. And so the idea here is that trigonometry refers to triangles. So because sine and cosine are defined in terms of triangles, we call them trigonometric functions. So you'll see that come up more as we start to learn more about sine and cosine and the other trigonometric functions. Alright, so that is a little overview of where the functions sine and cosine come from. Thanks so much for watching, and I will talk to you in the next one.